Thank you, Eyal. And now let's talk a bit about space and humanity. In the following panel, titled Remote Sensing in Support of Situational Awareness for the Civilian Sector, we'll hear about ways to harness satellite remote sensing for the good of the environment and life on our planet. I'm delighted to invite to the stage Ms. Dana Lynn Barnett, a senior satellite systems engineer at Elbit Systems, to moderate the panel.
Okay, good morning. So today we're going to talk about remote sensing, helping the situational awareness for the civilian sector. And I'm very proud to invite my fellow panelists helping discuss this important topic. As we've seen in the last few months, that remote sensing is crucial in understanding what's going on, not just in our daily, day-to-day life, but also in emergencies and human disasters. So I would like to invite Professor Noga Kronfeld-Shore, Chief Scientist, Ministry of Environmental Protection. Dr. Adi Nino Greenberg, Chief Scientist for the Israeli Space Agency. Dr. Tarin Paz-Kagan, the Remote Sensing and Agroinformatical Laboratory, the Jacob Blaustein Institute for Desert Research at the Ben-Gurion University. Mr. Roy Shiloh, the founder and CEO at Planet Watchers Agricultural Intelligence for the Insurance Sector. And Mr. Benny Maor, Senior Director, Head of Space Remote Sensing Business Unit at iStar Division in Elbit Systems. Okay, so welcome all, and thank you for coming. As we look at the usage of the space remote sensing in the last few months, I would like to ask you, how does remote sensing help the civilian sector obtain the updated ground situational awareness? And I believe I would like to ask you, Tarin, to start.
Thank you. So I think one of the images that I saw it a few days after October 7 was the image that was captured by Sentinel-2. I don't know if we can put this image. This image shows... Never mind.
Okay.
This image shows the large amount of damage that was caught in those regions. You can see the large amount of area with fires. One of the things that Sentinel-2's capture is the SWIR band, which is highly relevant to water absorption, but also can detect very clearly fires. And in here, what you can see is you can see the area where we've got the points of fire, car by car, house by house, which is, of course, stunning, first of all. But in addition to that, it's emphasized the importance of remote sensing in monitoring disasters like what happened in Israel in October 7. In addition to Sentinel-2, that just passed a few hours after the attack on October 7, there are additional satellites, as mentioned previously, with large amounts of information that can help us manage those areas, rehabilitate them, and create a new environment that people can go back to their houses and live in more friendly or more accurate environment for them. So I think that the satellite system has a very, very important aspect also in terms of managing area after disaster, as we currently see in here, but also for our everyday lives.
Thank you. Roy, yes, we look at this slide, which also shows us the mass damage in the agricultural areas. Perhaps we can help with your intake on this.
Yeah, of course. Thank you. First of all, as Tarin said, you know, satellites can be really useful, especially at this kind of times that you can see areas that it's very hard to reach to. I'm from an Israeli startup, so I will speak mostly about the startup scene. We have a lot of startups that are specializing in analyzing remote sensing data, satellite data. Some of those startups were able to assist after October 7th, but if, you know, to be frank, not enough. And I think this is part of the topics that we want to cover today, how we can establish, you know, the flow of information from the industry, from the startups, from the academy, into where it's needed. Yeah, that's it for now.
Okay, Benny, can you help us also understand how would you look from an old industry or more maintained industry perspective?
Yes, good morning everyone, or noon. Thank you for having me here. As I said, I will try to represent the point of view of the traditional space industry. At Elbit Systems, we are a center of excellence for the last 30 years. We are for space remote sensing, and we are actually the ones that provide the actual imaging payload and the camera that is going upstream and providing all of this kind of data. I think that this image is a very good illustration and a proof of concept of the capabilities we can have from space for this kind of disaster areas. However, the disaster areas are singular points in time. And in order for being able to supply solutions for that, we need payloads in space populating the low Earth orbit in a way that will enable day-to-day data for customers worldwide. And then on those specific singular times worldwide that you have disaster, then they will be over there available to provide real-time capabilities.
Thank you. And Noga, perhaps from your perspective, as we look at this, what can we do and use? I mean, is this just a chance that we have this image or that we can use it?
So I think that I'm the only one from the user's side. I'm not dealing with space or with remote sensing. I'm the chief scientist of the Ministry for Environmental Protection, and a major part of my role is to try and connect science and policy. And one of the main gaps, I think, is the use of data for decision making. And many of the decisions that we take have a spatial dimension. And I think that one of the best sources for spatial data is remote sensing and space satellites. So during the last year and a half, Adi and I and other chief scientists like Michal Levy from the Ministry of Agriculture have been working, trying to understand what are the abilities of remote sensing and on the other hand, what are the needs and how we can connect the needs to the abilities, and in what way we can create a data processing structure that will deliver the information that is gathered by remote sensing to decision makers like myself that don't really understand space but want to use the information that is created using remote sensing.
So, Adi, perhaps you can also add from your perspective.
Yes, thank you. So it's great to be here. Following what Noga said, actually we had a long process, and I think that the first challenge was to bring space closer. This is how I call it, because for us in the space ecosystem, space is very common and understandable, but for other users that works on the ground, it is not very clear. So bridging the gap is the first step, and I think we did a great process, if I may say. And in a larger perspective, I think that satellites are a long-term investment. As long as they're active, they provide data, and you can create great knowledge for various needs and a variety of users. And this is what we do in routine. We take the data and we try to figure it out and create knowledge and create database of answers to the needs that the users have. And when it comes to emergency times, we can benefit from all the hard work that we already did in the routine. So it is very important to take all the insights and all the knowledge that was extracted from the data and to benefit it, to update the situational awareness, especially in times like this. The Israel Space Agency considers space-based remote sensing and Earth observation to be of great importance, and we promote satellite remote sensing research. We have international collaboration. I can think of two major examples. We have the successful Venus satellite for agriculture, for precision agriculture and environmental monitoring together with CNES, which is a very successful project. And of course, the joint research with the UAE Space Agency together with researchers from Tel Aviv and Khalifa universities for environmental monitoring. So I think that this is what we are trying to achieve during routine, and maybe in the next step I will elaborate more about what we're doing in emergency times.
Okay, so we talked about bridging the gap, and in the previous panel they talked about the TRA levels. So how do we go for bridging the gap, and is there a difference in emergency times or in the Israeli sector emergency time? I will first ask you guys from the academy and from the industry on your intake.
So I think that there are several aspects that need to be considered. So first of all, data is available. We've got a lot of satellite and a lot of data and information that we can capture. But I think that the main part that needs to be emphasized is how we translate this data to knowledge, and how this data is transferred to the users, to the decision makers, to people that can use it and have some decision about the use of it. I think it's becoming more and more accurate and more important when we are under a time like this, where we need something that is crucial, need to be provided very fast, so we'll have the ability to have a decision about things. Additional aspect is the use of this information to rehabilitate area. And this is also very important, because after the attack or after the damage was already caused, what we need to do is we need now to rehabilitate and build a new environment. And for that, we need a lot of models and a lot of algorithms and a lot of information that will be translated accurately to the users. And this is, I think, the main step that currently missing. So we've got a lot of information, but it's not really available to most of the people, and we need to make it available. And we need to create a hub that will enable this data to be freely available to all users and all decision makers and all governments. I can emphasize it with one example, that it's based on an agricultural system. So for example, in Israel, we don't have crop modeling maps. And this is something that came from the government, from the Agriculture Ministry Agriculture Ministry, which needed a platform to monitor crops in Israel. And we took this opportunity and currently developing models together with the Vulcani Center, research from Vulcani Center, on crop mapping of Israel automatically in near real time. This requires integrating information from multiple satellite, developing the platform, inherit this platform into the GIS system of the government, of Agriculture, Ministry of Science. So they will be able to use it for managing those areas. So I think that the main idea is to move from data available to knowledge that is available.
So maybe I'll continue from here, from this point. So for us, as the industry, the traditional industry, we have the responsibility to keep providing these amounts of data for users and customers and startups and application developers to be able to do lots of work on it. And I think that we are now, we're all in really exciting times, because we're at a point that at least after 30 years, you know, in our industry have been solving the technological barriers, and we can provide nowadays solutions with regarding to spatial resolution, to spectral depth and spectral control, and spectral slicing, and providing whatever is needed in this domain, and also on the time domain and repetitivity and so on. But we have a limiting factor, which is the costs. And I think that nowadays our big challenge is to be able to provide all of this amazing stuff. In order to provide that, we need to lower the cost, and that's where we need to put our innovation and our scientific teams, and to find innovative solutions for how to do that. Because if we do that, the barrier is going to be very low, because the launch prices, as we know, are going down and down. So we need also the payload prices to go down. And then we'll have many payloads, many spectral bands, many data points. And then grinding the data with big data, with AI, will provide solutions to problems that we don't even know that exist now.
Yeah, first of all, I agree. I think in a few minutes, like we established in our discussion that Israel have the capabilities to launch satellites and payloads into space. We have the science, to support the analysis of the data. We have users that need the data, and we have startups that can help in order to make this commercialized and a service that is available and very simple to consume. Because basically in startups, this is what we do. We just simplify data. The data is already there, especially in remote sensing analysis. We just try to make it easier to understand. And Israel being geographically a very small state, we are very well situated to use this data and to have full coverage of the entire country. But as Tarin said, that's not the case. And even in agriculture, we don't have so many agricultural areas in Israel, but still we don't have good information about them. My startup is working in North America. Over there, every field is mapped. And those are vast and huge areas. And we are such a small country, and we didn't do it yet. So I just think it's really a matter of decision and switching the mindset, because there is value in that. And it's definitely an investment and not an expense. And once we figure out what the users need, we have enough resources to deliver it properly.
So let's talk about bridging the gap and finding these users. How do we connect the dots between the potential users and the analytics and the technologies, and how do we do this in the last few months?
First, I think we have to map the abilities and the needs, as I said, but this is not enough. So people in Israel are considered early adopters of new technologies, but unfortunately, that's not the case at the government. It is much more difficult to persuade the ministries to adopt a new technology and stop using the old techniques that they were using. So I think that we have to watch for opportunities, and the fact that we worked for a relatively long time and we got acquainted with all the abilities on one hand and the needs on the other actually enabled us to use this knowledge when urgent needs came up due to the war. And we realized that there are several difficulties. First, there was a problem sending people close to the border because of the danger, and we were trying to find alternatives for rescuing these people. So remote sensing was something that attracted interest, and we could relatively quickly demonstrate the abilities. For example, one of the things that my ministry, or there are several things that my ministry is interested in, damage to nature reserves and open spaces, pollution by oil or heavy metals. And one of the things that we wanted to do very quickly was the removal of asbestos roofs, both in the south and in the north, because once asbestos is bombed or burned, the cost of removing it is in order of magnitudes higher, and the risk is very high. So to start with, the Ministry of Agriculture and my ministry, Environmental Protection, started sending people to look for roofs, but then when we showed that we can actually relatively easily detect the asbestos roofs from space, it makes the work much faster and much more efficient, and we are now starting to promote asbestos removal using remote sensing for detection of the areas that are suspected as asbestos. And the other thing is damage to nature reserve. We can't fly drones now next to the borders, and we don't want to send cars into the nature reserves to see if something happened, because that causes damage by itself. So by looking at the NDVI and changes in the land, we can actually locate the suspected areas and approach them specifically and try to understand and improve the detection of areas that need to be reconstructed. We also have to allocate money for recovering these areas, so we have to get estimates of the sizes of areas that were damaged, and this can easily be done with remote sensing. So I think that once we will start using remote sensing now, because of the urgency and the need, it will be much easier to extend and use to other uses in other ministries, and I hope that this will happen now.
I would like to add a few things to that. First of all, as Noah said, satellites are our eyes in space, and when we can send people or drones or cars to a damaged area, we can use satellites. Another benefit is that because they are always there, we can go back and forth and to detect changes and to create insights and to create maps that change over time. So it is very important for our users. So what we did, because over the last year and a half, we worked with all these ministries and local authorities, we created a very large database of needs of all the users. And on one hand, and on the other hand, we created a list of all the satellites, of all the technologies, the remote sensing technologies, whether it's SAR or hyperspectral or whatever, that we can benefit from. So we came in very fast to the situation. And when the Tkuma project was formed or established, we knew very quickly that we can contribute to this important effort. So we created this cross-ministerial team together with Michal Levy, together with Elad Sagi, that is here from the Israel Space Agency, and others. And we try to detect the most important needs, and it's not so easy because there are many needs that are important, but we try to combine them with the needs that are low-hanging fruits, so we can quickly achieve a response or capability to help in these needs. So the combination between these needs, I think that this is one of the things that we are going to work on very quickly. Of course, we need a budget, and I think that the list is only getting along as we talk, but this is very important. So I think that satellites have a very important role in this war.
So if we look about, and let's imagine for a second that we have the budget, we have the money. In the next emergency, whether it's a natural emergency or anything, from global disease or whatever, something needs, and we need this data. How do you see, what's your dream of this whole happening very quickly? I mean, in each of your perspective areas, how do you see this case following? Like, what do you do?
From my perspective, first of all, I think that in order to be ready in an emergency, we really have to use this on routine. And hopefully when emergency comes, the use will keep feeling like a routine because it's already being used and we don't need anything else and the data is already there. As I said before, the satellites are always there. They also go back in time, which is critical many times. Drones cannot do that, for example, or airplanes. So I really think that there should be a significant investment in building the capabilities and creating the connections that are needed in order to create the data. I don't think, by the way, that it's so expensive. And then just keep updating the information layers. But I think most importantly, everything has to come from the users. There are so many things you can do with remote sensing, too many things, many times, and once we know what needs to be achieved, we can make sure that it happens. And many times you'll find that, startups or people, like my startup, for example, is doing something very different, but can I don't know, detect, damaged roofs? Yeah, okay, it's not what we do, but we can do it. And if we can create a community that can share, codes and analytics and continue to improve that, I think everyone will benefit.
Yes, so as you're mentioning, yes, the capabilities are immense. In our company, we have a lot of electro-optical solutions for airborne missions. We can provide detection of a vast amount of materials from space using hyperspectral imaging, and it's endless. When you talk on spectrum, then it's endless what you can do from remote. And I think that the vision should be that we will get to a point that the space is democratized. So the many dispersed customers can have access to all of this depths of data. And the way to do that is to aggregate and to do partnerships and to get together on levels of countries, because it has to be on levels of countries, and put those customers together and aggregate the financing under agreements, and then you can build up projects that can launch this kind of capabilities. And another way of doing that is, and there is going to be a panel after lunch about this, is by combining the defense industry and the defense side of the government and civil applications and finding dual use for existing and future remote sensing platforms.
If I can add, so I think that there is some pipeline that we need to go through. So first of all is the data, and the data needs to come from a fusion of different sensors with different special spectral temporal resolution. I think that today we have the ability of working with hyperspectral satellites from different countries that launch hyperspectral satellite, which is very, very important in terms of detecting and using it for different application in remote sensing. The abilities now are available, which something a few years ago we can just dream on. So first of all is the data and the ability to fuse this data. Second of all is to create that this data will be available, as mentioned previously. I think that the most complicated part is to create the models and to create the algorithms and to develop the approach. In the previous session, they mentioned, for example, the use of a satellite to detect sheep and goats in grazing systems. So the main effort is to develop the system, is to develop the application, the models, the accuracy, and this usually requires a lot of additional infrastructure, sensors on the ground, additional information from flags tower, or from whatever we want to monitor, and then to take this information, which need to be very accurate and very reliable, and transfer this information to the users. So I think that there is a very clear pipeline that needs to be applied, and we are somewhere in the middle in those pipelines.
I'd like to add a very practical thing that I think that should happen and actually started already. As ministries, we don't understand in space or in remote sensing, and we need someone that can answer our questions, like Ilan and Adi are doing. So I can come to someone with the needs, and they are the ones who will give me the solutions, because even if I know something about space or remote sensing and I issue a call for proposals, I don't have the ability or capacity to judge them. And therefore, I think that there should be, as happening now, a governmental unit within this Israeli Space Agency that work with the ministries and help us use remote sensing more efficiently.
So I think I want to thank you all. I mean, we saw today the infrastructure and the users and the potential, and we know that there's a great work that is underway, also helping during the Tkuma Directorate and in other cases, and it's my hope that next year we can come with an even bigger message showing how this infrastructure is already in place and how it is helping us in our daily life. So I want to thank you all, and thank you all for listening.
Thank you.
I'd like to thank Ms. Dana